Hi, welcome to my channel on technology space with machine learning and artificial intelligence. So the today's topic is what is extreme data? What is extreme data? Before that, let's talk about what is big data, because extreme data can be an extended version of big data. So what is big data? Even before answering these questions, let's talk about what is data. What is data? Data is information stored in a specific form. So this form is utilized because it is easier for us to move this data from one place to another, or it is easier for us to process this data. In this presentation, I'm talking about three different formats. I think three different forms. This is due to the applications of machine learning algorithm. So the first form is numeric, or the numerical values. Often if you have a systems being facilitated with various sensors, these sensors can collect various numerical values. So these values create these type of data sets. And regression type of machine learning algorithms often utilized to model these numerical values in this research area. So the second form of data is images. You can imagine most of these deep learning frameworks in machine learning are based on image classification type of algorithms. So I would consider image as another form of data. So the third form of data I would classify it as words or sounds, because another machine learning area of natural language processing, often based on these words or sounds. So that way I would classify as another form of data. At some point you can argue these images and words are stored as numerical values, of course, but since how the machine learning algorithms being utilized to facilitate this data is the basis that I have used to classify these specific forms in the data sets. So let's try to answer the question of what is big data. Big data being classified having four features, which is called 4 V's in big data. So the first feature is data volume. That means the scale or the size of the data. People often think the wording big data we utilize because these data sets is really large. But I would think we utilize the word of big data because of the complexity in these data sets rather than the size. So the second feature is data velocity. That means streaming of the data. When you monitoring a system online, you can collect quite a lot of data online in real time. So that can be another feature in this type of big data sets. So the third feature is variety. That means different forms of the data. Data can have various forms that we have discussed even in the previous step. And the fourth feature is the data veracity. This is the uncertainty or the quality of the data. As I have mentioned, various sensor data sets can have a large amount of data anomalies within these data sets. Let's try to discuss some solutions to the big data features that we have discussed in the previous slide. Here I am presenting the process of digitalization. So this process being presented in another video, and I will place the link below to this video if you're interested in going through that process. For the simplicity, I would say that digitalization is a process of transforming data into useful information and then into smart decisions. In this slide, I would like to discuss what are the solutions we can provide for these big data features that we have discussed previously. So the feature of data volume and the data velocity often can be facilitated under the data management layer. So when you have a data management layer, that can provide the storage space for this data, and it can also provide facilities to handle these data online, specifically when you're talking about real-time data. But when you come to data variety and veracity issues, different forms of data and the data quality issues, the solutions should come from the data analytics, because these data analytics should provide solutions to the data quality issues, specifically identifying data anomalies and recovering such data anomalies. And then when you come to the modeling part of the data, having different forms of the data, these data analytics should provide solutions. Since we have discussed about the big data, now it's easier for us to answer this question: what is extreme data? It's probably going to be big data with additional features or challenges. So here I am presenting a data set from AIS data from various vessels. This figure been created by one of our research publications. So if you're interested in that, please refer to this publication. So let's try to answer this question: what is extreme data? If you think about a system which is collecting, having 100 sensors, these 100 sensors will collect 100 parameters in a single time instant. So that means the whole data set consists of 100 dimensions. So often to visualize these 100 dimensional data sets are extremely difficult. So what you do generally, you cluster these data in a high dimensional space and then project it into a 2 or 3 dimensional surface for us to visualize this data. And then these clusters can have different colors. So when you've done such type of approach, you would see a data set like that. So it shows how complex these extreme data sets can be. And you have to remember, when you're looking into such type of figure, you are looking into a shadow version of the extreme data. So let's try to discuss what are the additional features in this extreme data. So the first feature is the clustered. So that means these values exhibit some sort of a group behavior, and then this group behavior or the clusters are distributed throughout the space. So you can see in this figure that that representation is given in a more precise way. Then the second feature is dispersion. So then these clusters can be stretched or squished. So you can see different data clusters having different shapes and sizes. So that is another feature in these extreme data sets. And then the third feature is the Gaussianity. So these clusters can be distributed as a Gaussian or non-Gaussian types. I think majority of these clusters are non-Gaussian. So that will give you like extreme conditions into these data sets. You should remember, when you're dealing with a non-Gaussian data set, it is extremely difficult to model. And the fourth feature is the sparse, or the actual values are missing in these data sets, or these data may have zero values. Often zero values can create a noisy or unwanted conditions within these data sets. So the missing values often we classified as a nan or not a number. So when you have such type of situation, often you have to replace these nans by some sort of a value which is based on either interpolation or extrapolation of the data set itself. And so the fifth feature is the insufficient. That means actual values are insufficient or actual values are missing. So this can have some sort of a variation between the actual value versus the values existing in these data sets. And then the fourth feature is the extreme variation. So when you have some sort of a mean value and a distribution of the data, there can be data points which have extreme variations within these data clusters. Those data can often create outliers within these data sets. And the last feature is the periodicity. There can be non-periodic or periodic data clusters within these data sets. When you're dealing with a non-periodic data set, it would be somewhat easier to model, but when you have periodic conditions, these data can create quite a lot of noisy conditions, specifically around the mean point. So that can create additional challenges in modeling these data. I would expect to discuss all these features in a separate presentations, but here I am kind of introducing these features which is exhibit in these extreme data sets. I think we realize these features are so important and need to find solutions to these type of features in the future research directions, because otherwise if we couldn't find solutions to these type of features or challenges, we would have extreme difficult conditions in modeling this data or facilitating this data towards digital twin type of applications. Since we had an extensive discussion on extreme data, let's try to give you a flavor of how to model such type of data sets. Here I'm presenting in my right hand side figure a simplified version of an extreme data set. As you can see, it consists of several data clusters. Some data clusters are Gaussian, some data clusters are non-Gaussian, and these data clusters are existing in a high dimensional space. And you should remember these data clusters often relate to some sort of a localized operational condition of the system where these data clusters, these data sets being collected. So the normal data clusters can be a part of these extreme data sets. And then these data sets might consist of anomaly data clusters. Often these anomaly data clusters can relate it to some sort of abnormal operational conditions or the sensor fault condition of that respective system. Again, this can be some sort of a localized abnormal operational conditions of the system itself. And then there can be data anomaly outliers. So these data anomaly outliers often can relate to some sort of a sensor fault condition or a transient condition of the system when these system moving from one localized operational conditions to another localized operational conditions. These type of outliers or anomaly outliers can exist within these data sets. So now we can imagine this way we can kind of put these extreme data sets into a mathematical framework, and then this mathematical framework can support the development of a digital twin, and that will also be discussed in these future slides. So now you probably realize that my discussion on extreme data somewhat biased towards the numerical values. Yeah, that's true, because I'm handling quite a lot of sensor data from various vessels. So most of our research work being focused on then handling numerical extreme data sets under the shipping industry. So here I'm trying to present a sample version of such a data set. As you can see, the first column in this data set consists of the timestamp and then various parameters that are related to a ship operational and navigation conditions have also been presented in this data set. So if you pick a single time instant in this data set, you can see there's a timestamp and then a bunch of values that are related to various parameters in this vessel. One of our research studies, we identified that 55 to 65% of data instant can consist of one or more types of data anomalies within itself. So that means within this single line there can be one or more data anomalies. So what may be the solution? Often we cannot drop out 55 to 60% of the data set itself, because one or more data one or more data points having data anomalies in each of these time instant. Rather, we have to recover this data within the data set. So one way to recover this data is utilize developing some sort of mathematical models, and based on these mathematical models we can recover some of these data anomalies. So that way at least we would be able to recover up to 95% of these data anomalies. And the research outcome that is related to these data quality issues is presented in this specific publication. So if you're interested, you are welcome to go through with this work. So that's pretty much it in this presentation. So hopefully you have enjoyed this specific topic, and so if you are still interested, please stick around in this channel. Thank you.